actually, have anyone in this class has any experience with machine learning?
No, sir.
Oh,
I don't.
No.
Is that going to be a problem? I guess. Is that going to be a problem?
No. If you haven't done any machine learning application yet, this will be your first. And please be patient and keep up.
Okay, sir. Thank you. Thank you.
Be patient and keep up. After this, you will feel you're going to have a new knowledge related to machine learning. Okay, I'm going to present you the new slide. Okay, hello everyone. We're going to start the class with machine learning classification with Google Earth Engine. So actually, previously we have already created mangrove map using mangrove vegetation index, so using algorithm. And next, we're going to use machine learning based classification with Google Earth Engine. So actually, if you go to supervised classification here in Google Earth Engine classification, you can see that there are only 5 steps. There are only 5 steps in the supervised classification. Actually, it requires more steps than it is stated here. So if you only following the tutorial that Google created, you usually get stuck and because it seems not to be working. So I'm going to give you an overview of what the workflow should be in using machine learning classification with Google Earth Engine. So the one with black font is available at Google's tutorial, but actually you need the blue ones too before you can come up with the training data and then create the classifier in order for the machine learning to work. So the first we should do always start by delineating our area of interest. So always start there and then prepare the image for analysis. If you want to use Landsat, you can use Landsat. Sentinel, you have different way for calling Sentinel, and MODIS you also have different way to call MODIS. So you have to prepare the image for analysis, and then the once is missing in the Google Engine tutorial is you have to select and stack bands first for analysis. So this one's actually missing in the tutorial in Google tutorial. So please, instead of using the Google's tutorial, use this workflow for image classification with machine learning for using Google Earth Engine. Okay. So the first step, you have to delineate the your area of interest. So you can open your Earth Engine. So you can use available asset, upload a new asset, or use the geometry tools to draw your area of interest. In this exercise, we're going to use geometry tools to draw our area of interest. You can create a new script. You can create a new script, a fresh new script, and delineate again the area of interest. And then don't forget to name your area of interest as AOI. I'm going to, okay. Okay, I'm going to create a new okay. Okay, we're back to the UK. Okay, Ujung Kulon. This is the UK in Indonesia. So the first thing we do is to create the AOI. Always start with this geometry, get configured name as AOI. Don't forget that for the area of interest, always use geometry. Don't use feature or feature collection. Okay. AOI, and then you can uncheck AOI like this, so you don't get to be distracted by the polygon. Okay. Okay. Afterwards, copy and paste this script for image analysis. As you can see here, we're going to use Landsat 8 surface reflectance composite. Okay, I'm going to pause and copy paste the script. Okay, I'm going to copy paste the script here. Okay, maybe to help you, I can copy it to the chat. Okay, chat. So we have the second step completed. We can click run. As you can see here, we have the composite of Landsat 8 surface reflectance. We can continue to the next steps. Okay.
Yeah, sorry.
Anyone experiencing problem?
I would like to know where you selected, just to follow like the previous class.
First, I created the area of interest. This one.
Yeah, I mean the location. The location.
Oh, the location. So it's entirely up to you. But if you want to know where the location is, you go to the Indonesia, zoom near to Jakarta, and in the peninsula, you have a little island.
Oh, good. I get it now.
Okay. So use this island as the, oops, sorry, not a very good example. Okay. Okay, rerun the script and we have an image. Okay. Now we continue. Oops, sorry. Continue to step 3. We have to select and stack band for analysis. So first we're going to mask the area for with Hansen image. We're going to mask the water area, and then create a composite for only land area. And then this is the most important part. We select the band that we're going to use. So we don't use all bands, but only the bands that we're planning to use. And then we create a property called habitat. Okay. Okay, so we create the bands Copy and
Not seeing
paste.
your
Oh, sorry.
screen.
You can see your screen.
Okay, sorry. Copy and paste. Copy and paste it to the code editor. The step 3. The step 3. Copy and paste. So you have a handsome image that you're going to use to mask the water area. Okay, and this script is for water masking. And then the most important part is this one. This means that you are going to select which bench you're going to do the analysis, and this is the property of the feature collection that we're going to build, that we must create the property that which define the input for the machine learning classification. So we're going to run. We're not going to get any visualization here. So there's no visualization here. Actually, you can uncomment this this line map at layer. So we can have the Landsat 8 line composite, and you can comment the composite layer, map at layer composite, for us to make the composite layer not displayed in the map viewer. So we're going to switch to only line composite. Okay. Okay, there you go. Okay. Okay, as you can see here, it's much easier to be viewed if we only focus on the land composite. Okay.
Hold on, I think you modified the code that you gave us. So we're just trying to catch up there. Sorry.
Yes, yes. Modified this code. Previously, you have something like this. You have forward double slashes twice in front of this one, but now you can uncomment this and then add comments, add double forward slashes in the map at layer in line 22. So instead of having 2 layers, we're going to have 1 layer, which is the mask at composite. So the mask area. I'm going to copy and paste the new section in step 3 that I've already modified to the chat box. Okay. Okay. If you still uncomment this script, the line 22, it's fine. And you're going to have 2 layers, the composite, and then the land composite. So you're just going to have 2 layers. It's okay. It won't affect our analysis. Okay. I think up to this step, you can continue. And afterwards, this is the most important part. You have to create a training data. So training data, there are 2 ways you can create a training data. You can use your own training data, or you can use the geometry tools to draw the area of your interest. So when using geometry tools, you can use the visual interpretation that I've already shown you before previously in the previous session. But you can also upload your geometry if you want to. If you already have done surveys, you can upload that geometry and then use it as a training data. Okay. Afterwards, you add property and class code in the property and value. And the last thing you do is merge your training data using this code. So I'm going to copy and paste the code, and then I'm going to create the training data. I will show you how to create the training data.
We're supposed, okay.
Okay, now we create the training data, use marker instead of Polygon. The AOI, we're not going to use AOI. Create new layer, geometry. The first one, I think, Mangrove. We use geometry, feature collection. Okay, and add property habitat value as 1. Okay, as you can see here, the value of habitat is the same with this class property. Okay. Okay, and oh, I forgot. It is better that you rename your as a best practice your feature collection and name it as Mangrove Training, in order not to be confused with other area of interest. Maybe you want to create other polygon, so it will indicate that the one labeled as training will be used for machine learning. It's much easier for us to understand. Okay, Mangrove Training. And the next thing you do, you want to identify areas that you think as mangroves, such as this. I'm going to use the satellite, and then just click the areas that I consider as mangrove, such as this one, this one, this one, this one, this one, and then try to find other areas that are considered as mangrove. Oh, you also have this one. Oh no, this one is coastal vegetation.
Mr. Safran, I think Anggia have a question.
Okay, please.
Can I share my screen?
Okay, please do. I'm going to stop sharing.
The water still show up.
Oh, go to layers. Go to layers. In the map viewer, go to layers.
Yeah.
This one means that you only display the composite. Go to the geometry. Go to the code editor. Go to the code editor. Scroll down a little. The code editor. Scroll down a little. Okay. In line number, scroll down a little. Down. Okay. In line 31, line 30, uncomment map at layer. Yes. Please run the script again. You're going to have 2 layers. Inactivate the composite layer. Yes, now you have land composite. Okay.
Thank you.
Okay, you are welcome. Okay, now let's us continue with the digitation process. So this is the area where we found that there's possibility of mangrove. Oh, we have mangroves here. Okay, we have mangroves here. Oh, we have mangroves here. No, it's not mangrove. This is coastal vegetation. Coastal vegetation. Oh, we have a little bit of mangroves over here. Very small area of mangroves. So we only get 17 points. It's better that you have as much point as possible, but in this training, it's okay if you only get 20 or so points. It's fine. No, it's La Chamara. Okay. So this this is the inner side of this one is mine. So this area.
Mr. Safran, I think
Yep.
Patrice raised her hand.
Okay, please, Patrice.
Hi, in my layers, I'm only getting the Landsat 8 land composite. I'm not getting the other composite, or what do I do?
It's okay, it's okay. You only need the Landsat 8 composite. It's fine.
Okay, thank you.
Okay. Okay, you are welcome. Oh, this one's mangrove.
Sir, may I ask?
Okay, please do.
I want to share my screen.
Okay, please. Stop sharing.
Is my screen shown? There is a warning, cannot read properties of null. Reading TTA.
Oh, I think it's I think you are experiencing error because an incomplete code. So I'm going to copy the step 2 and then step 3 to the chat box, so you can copy and paste.
Okay.
So this is the step 2. And this is step 3 and step 4.
I have a quick question.
Okay.
Thank you, sir.
The Landsat resolution isn't as good as the satellite resolution.
Yes.
Can I click the training areas just viewing the satellite resolution? Because the Landsat being 30 meters or whatever it is, it doesn't give you a good enough resolution.
Yes, you can, but it will be more difficult for you to identify the mangrove visually if you use the Landsat 8 instead of the satellite view from Google Earth Engine. You can compare it. I can show you the difference.
Okay.
I can show you the difference. So if you find it here. So if you use the composite instead of the satellite, like this, it is very difficult for you to discriminate between mangroves and non-mangroves area. You see, it's very difficult unless you use different band combination such as red bands and others. But generally, it is much more easier if you use the satellite. Since you can discriminate like this. You can discriminate between mangroves in the right side and terrestrial vegetation in the left side, as you can see here. See, there's a delineation between mangroves and terrestrial vegetation here. You can see it quite clear. But if you use the Landsat composite, well, you can see it. We can see some differences here. but in other areas, it is very difficult. Just like this one, if we use the satellite, we can see that this area are actually mangroves, but this area with almost the same almost the same color is actually terrestrial vegetation. So therefore, we need the satellite base map rather than the Landsat 8 composite to do that. Okay, is it clear?
Yes, yes, thank you.
Okay, now we're going to create another.
Excuse me, sir.
Okay.
Can I have a
continue.
question?
Please.
Can we use Polygon as the mangrove training data instead of a point?
Yes, you can. Yes, you can. But actually, if you have, if you use Polygon, Earth Engine will reduce the polygon into one value. So they will use the mean value of the polygon, and sometimes it will make your analysis become biased because you didn't use the actual pixel value. Instead, you're going to use the mean of various pixels inside the polygon. So therefore,
thank you.
it is better for you to use a point instead of polygons.
Okay, thank you, Mr. Safran.
Okay. The next thing we do is we identify where areas are actually bare substrate. We create a collection called bare training feature collection. Add property habitat as bare, and value is 0. Okay, value is 0. So we find the bare substrate in this image. Okay, especially, oh, this one, this area. Okay. Okay, yeah, you have some patches of bare substrate here. Especially in the, okay, somewhere here, here we have the bare substrate. You can also use the Landsat 8 composite to know the extent of the of your map, so you can turn it on and off. Okay, I think this one's bare. Okay. So not there. Oh, this one. Some patches of bare substrate.
So, sorry, can you remind me the values of bare substrate again?
Bare substrate is 0.
0, okay.
0. Property, in the property habitat, the value is 0. Okay. This one's bare substrate. Okay. Okay. At least you have 20 training points. Okay, it's bare substrate. And try to spread it as much as possible across the area of your interest. Okay, check. Okay, one more. Okay, this one's per substrate. Okay, and create a new layer called terrestrial vegetation. Okay. Other, so there will, this is used for terrestrial vegetation. Feature collection, we add habitat S2. S2. Okay. Now we can just, okay.
What if you did not include terrestrial vegetation in your AOI? How can we edit that?
Yes. So if you didn't include the terrestrial vegetation, the machine learning will not be able to distinguish between mangrove and other vegetation. So I'm going to use here as other vegetation. It is important that you have training for all possible class. Therefore, you can get the most out of the machine learning algorithm in your analysis. If not, the mangroves will be mixed with the vegetation class, and it's very difficult for you to come up with a conclusion with the image from the machine learning. This one.
Okay, what if there is no terrestrial? So the place that I'm selecting, it's an island, a key that doesn't have terrestrial vegetation.
Oh, it's okay. You don't need to include it in the training. Okay. As I said before, you should include all possible classes. All possible classes. If the class not present, then it's impossible to make. And then the next thing you do is you merge the training data into a new collection. Okay, you merge it into a new collection called new feature collection, new FC. It contains of mangrove training merged with bear training, and then merge again with other training. So this is how you do creating the training data in Google Earth Engine by digitizing the data in the map viewer. Okay.
Sorry, Mr. Safran. Sorry, Mr. Safran.
Yep. Okay, please.
For the other training I forgot the properties. Is it habitat?
Oh, sorry.
Oh, okay,
Two.
okay. Two. Okay, thank you.
Two.
Sorry, Mr. Safran.
Okay, please.
How to delete the last point I have defined?
Oh, just use the pen tool and then click on the point that you want to delete. You're going to have this.
Oh, thank you.
Okay.
Sorry, Mr. Safran, one question again.
Okay.
So the other training is for the terrestrial vegetation?
Yes, it's for the terrestrial vegetation.
Oh, okay, thank you.
Yes, but if since in this example, in this area, we only have 3 possible classes: the other vegetation, the bear substrate, and then mangrove. But if you are in another location that has different possibility of classes, you can modify the number of feature collection you created, but don't forget to also modify the merge training data script according to your needs. Okay, therefore it is much better if you currently during this training you focus on only three possible classes, and then you can continue later on using more classes for your own analysis. Okay. Okay, then let's continue to the next step. Okay, if you can get something like this, Now we're going to instantiate a classifier. So the first thing you do is to sample the training data using the new feature collection. You sample the training data using the new feature collection according to the bands defined in the variable bands. Okay, and the property defined in variable class property. This is how you do it in Google Earth Engine, training the data. Okay, after you instantiate the prepare the training data, it is important that we divide our data into two sets. The first set is the training set that we will use to train our data and perform the analysis. And the next one is the test set, which we will use to test the accuracy of the image that the classification that we have created in the image analysis process using the classifier. So this is how you do it in Google Earth Engine. Okay, I'm going to copy and paste. I'm going to copy and paste this script to the code editor. Sorry. Okay, and then click run. Okay, as you can see here, this script is for creating the training. So the training data that we use, the new collection, will be used by the classifier to train the mass composite using the selected bands we declared earlier with the feature collection. We specify earlier, and the class property. So you're going to have something like this. Okay. Now, using the script, we add another column. Called random. Which what it do is to generate a random number between 0 and 1, and we're going to split the data based on the random number 70% for training and 30% for testing. So with training partition, using the random column, this one, the random column, we filter the random. So we filter the data, the random, which is lower than the split value, as training partition. And then we also make another filter where the testing partition contains the data from using the random column where the value is greater than or equal than the split value. So this is how we're going to divide the training data into training partition and testing partition. Okay, you can just click run. Actually, you're not going to get any output. Okay, so we can continue to the next step. Okay, the next step is you have to train the classifier using this code. Actually, Google Engine has a lot of algorithm for machine learning. You have Maxent, maximum entropy, random forest, CART, naive bias, and other classifiers. So this one I'll be using is random forest because it's one of the most used classification algorithm in Google Engine. Using the training partition with class property we have defined, and input properties we defined before as bands. This is the general rule, the general way to train your classifier using Google Earth Engine. So we're going to paste it here and click run. Actually, nothing happened, but it's already in the system's memory. Okay, now we continue to the next step, is image classification using this step. So this one is to classify the image. You can use classified your classifier, RF classifier. Use your classifier. So you declare a new image called classified random forest, a new image called classified random forest from the mask composite, which bands we already declared before, and we classify the image using the classifier we create previously. Okay. Afterwards, we create the palette for classification, where this value is for bare substrate, this value is for mangrove, and this value is for other vegetation. And then we display the output of classified image using the visualization parameter and give it a label of mangrove habitat. This is generally how you classify an image in Google Earth Engine. So I'm going to copy and paste the script to the code editor. Paste it here, and then we run it. We're going to have a new okay. See, we have a new classified image. The green one is the mangrove, while the orange ones are bare substrate, and the cyan, the bluish green one, the cyan, the bluish green one is other vegetation. So actually this classification is not very accurate because in the center you still have a lot of terrestrial vegetation identified as mangrove, but that is due to we only have very few sample. But if you extend your sample maybe more than 30 or maybe 100 points for each feature collection, then you will get a better and smoother classification. Okay, so I'm going to copy and paste the final step. I will copy and paste step 5 to step 7 in the chat. This one. Step 4, we're going to copy step 5. Step 5, this is step 5. Step 5. And then this is step 6 and step 7. Okay, this is step 6 and step 7. Okay, now you have completed the classification system using machine learning. Oh, I forgot to copy and paste the output. Sorry. Step 7. Okay. Okay, that is the full script until step 7. And then click run. Now, anyone get any result? Let's see what you have. Okay, please display it. I'm going to stop sharing.
Can you see the result?
Okay. Okay. Okay, what do you think about the classification? Is this classification correct or not?
Yes, I think it's almost correct.
Almost correct.
Yes,
Okay.
because here is only some mangrove, and
Oh.
as this is village, so they accurately classify, but there are still some error.
Oh, some error.
In the
Okay.
village.
Okay. So I think you've done a good job by providing the a good training sample. That's why you get this result. This is a good result. And well, I think we're going to see another paper published based on this training, Mr. Bayu.
Yes, sure.
No, so this is
But,
a good classification.
I have some other observation in the previous 14. It means 14 exercise.
Okay.
So I'll discuss it later.
Okay. Okay. Nice. 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 This is a good classification result.
Well, I have only this amount of training sample. Not very large, only 35 in S class.
It's okay. It's okay as long as it can display the right classification. I think you'll be okay. You'll be fine.
Thank you.
Okay. Now, anyone want to show us your future research?
Me. I
Okay,
lost
please
my
do.
connection, so I will share my screen.
Okay, please do.
This is enough for the bear training?
Yeah, actually, it is better if you have more points. But for this exercise, I think it's fine. I think it's fine.
And the layer, is it correct? Mangrove
Yes,
habitat.
yes, correct. It's already correct. Yeah, I think you successfully create the classification. And in order to improve the accuracy, it is better that you add more points later on. But currently, you have succeeded in implementing machine learning in Google Earth Engine.
Okay.
Okay, nice. Anyone want to display their result?
Yes, I do.
Okay, please do. Oh, nice. Is this correct? Actually, is this correct? The classification is correct.
Some areas, the bare areas look out of place, but
Okay.
yeah.
According to you,
Yes, according to me.
yeah.
And there's supposed to be mangroves around the edge going around.
Oh,
So,
okay. Okay. I think you can increase the number of training area, and also maybe you can also increase the your area of interest, your AOI, to include more mangroves area, in order for the classifier to learn which area are actually mangroves, which are not. But in general, you have successfully created your classification using machine learning. Okay. Okay. Congratulations, Patrice. Okay, now.
Mr. Muhammad has.
Okay. Please display. Please share your screen, Mr. Muhammad.
Yes.
Yes.
Yeah. This is my screen. Can you see my screen?
Yes. Yes.
Yes. I just want to ask, because in this area in my cursor, I didn't mark it and then classify as a bear. Is it good or not?
Okay. Okay.
It's totally
Yes.
classified as bear because I didn't mark mangrove or
Yes. So this is interesting.
Yes, I have 20 points every mark, but I didn't mark in that area.
Okay. I will show you this, the result of my classification. I'm going to share.
Stop share?
Yes, I will share. Okay. Okay, as you can see here, in the mangrove, I only focus on this area. Actually, this is the example I prepared earlier. To show you the capability of Earth Engine to predict which area are actually mangrove outside of the training area. So as you can see here, going to add new layer. So as you can see here, this area, this area are actually mangrove, and I put training samples over here. And also this area are actually mangrove, and I put training samples over here. But this area, even though it is mangrove, I didn't put the training samples over here to illustrate to you that Earth Engine is capable of predicting mangrove area by learning using the sample we created. That's why it's called machine learning. So this is one of the advantages of using machine learning for supervised classification using Google Earth Engine. So your result is definitely okay as long as it is the correct one. Okay,
Yeah,
what do you think?
maybe want to ask you, because in that area is classified as the bear, it's a settlement.
Yes.
Maybe I need to add more geometry, other marks.
Okay.
Then habitat number 4, maybe number 3.
Oh, you can do that. Yes.
Yeah.
Yes, definitely. You can do that. And also, if you want only to focus on mangroves, it is okay to classify the other land cover as other training, since you only want to focus on mangroves. And even if you want to focus on mangroves, you can also divide the classification into more detailed classification, such as healthy mangrove or degraded mangrove and something like that. So it is better for you actually to test which classification system is better by reiterating the machine learning process and the data collection.
Okay, thank you.
Yes, you are very welcome. Okay, anyone else want to share their screen? I will stop.
Want to ask, sir.
Okay, please do.
For the palette color code, is it HTML color code or what? So
Oh,
when
yes.
I work, yes, it is
Yes.
HTML color code.
Yes, I will show you where to get it in the. Okay. You can use this one and copy it. So you have the same color between the training data and the classified data. See here, the bear substrate has the same code between the geometry and the palette, because I copy from here and paste it here. So it will be much easier for you to create the palette that way.
Okay, thank you, sir.
Yes, you are welcome. Okay, anyone to share the screen before we continue to the next step? Okay, not yet. Okay, not yet. Therefore, we can continue to share.
Start, Saffron.
Okay, please.
Can I ask something about the previous script number 14?
Number 14. Oh, okay, maybe we continue the script until it complete, because we still have the accuracy testing after this.
Okay, sure.
Okay. Okay, this is the accuracy testing next. So to estimate accuracy, you have to copy and paste this following script to the code editor. So what this script do is first, using the previously divided training and testing partition, we create a new two confusion matrix. So for the training accuracy, we use the resubstitution error matrix, which is the training accuracy itself, and then calculate the overall training accuracy. So the training accuracy will tell you how much the classification resembles the training data. So this is why it's called the training accuracy. And then after that, we classify the test feature, the testing for partition, to come up with the classification for the test partition. And then we create an error matrix between the classification and then the habitat properties that we created before in the feature collection development process. Now we create the error matrix and then we print the test overall accuracy. So after that, we calculate the producer accuracy, consumer accuracy, and the kappa test. So I will show you how it's done. First, you need to copy and paste to the code editor. Copy and paste to the copy and paste to the code editor, and then click run. Oops. Okay, and then click run. Okay, as you can see here, we have the substitution error matrix. So out of the 22 from class 0, the bear training, yes, the bear training, all of them are classified correctly, and so on. So this is how you read it. And then training overall accuracy is 1, meaning that 100% of the training data, the classification fits the training data. Okay. Now the error matrix using the classified the testing partition, as you can see here, we create the error matrix and then calculate the test overall accuracy. Usually the ones used for accuracy testing is this one. Well, it's actually quite high because we only have a very few testing partition. So 0.96 means that you have almost 97% of overall test accuracy of the classification we created earlier. So this is how you do accuracy analysis in Google Earth Engine. Now,
one quick question.
Okay, please.
Yeah, how did you get when you're checking the like the training points?
Yes.
That I didn't quite see where you clicked to see how much of those training points were actually accurately mapped.
Oh, okay. You can go to geometry points. As you can see here, there are the numbers of training points. Bear training 37 points, Mangrove training 26 points, other training 39 points. Something like this one over here. Can you see my screen share?
Yes.
Yes, okay. This is the one. Okay. So I'm going to explain a little about the type of accuracy. So the user's accuracy, correspond to error of commission. It means that inclusion. So why would Berland get wrongly classified as mangrove in the mangrove class? While producer's accuracy correspond to error of omission, it's exclusion. In example, why would a Berland not classified as Berland in Berland class? So to make it simple, User's accuracy means you get wrongly classified as the other class. Wrongly classified is the other class. In the same class, it's wrongly classified as the other class, while the producer's accuracy means that why your class is wrongly classified, not in that class, So this is the difference between user's accuracy and producer's accuracy. And the kappa test is usually used to measure the reliability for qualitative item. So it's actually it's actually a simple percent agreement calculation, because the kappa takes into account the possibility of the agreement occurring by chance. So if it's larger than 0.5, then it is usually bigger. It is usually a good classification because it is better than it is better if it's if it is better rather than it is compared to it is done by random chance. So it's something like this. Okay. You can see here. Okay. You can see here. This is the producer's accuracy, and this is the consumer's accuracy. Okay. And then this is the kappa test. So 0.98948 is a very high value for the kappa test. Okay. And then the final is the step is the export output of the asset, both to asset and to Google Drive. I'm going to copy it to the chat box. Okay, like this. And you can complete the script for machine learning with Google Engine. From step 1, delineating area of interest, until step 9, exporting the output. Okay. Now, let's see the result of the error estimation, accuracy estimation. Anyone want to share their accuracy estimation result?
Yeah, I can share.
Okay, please do.
Can you see?
Okay. Well, actually, you have a very high result. And the producer accuracy almost 100%. Because the producer accuracy almost 100%, the consumer accuracy also. So this is generally a good result for you. And then the training almost won. The training almost won, but the testing also 0.96. Okay, nice. I think your training sample really represent the actual condition of your location, because you have a very high test overall accuracy.
Yeah.
Okay. Is there anything you want to add? Maybe you want to elaborate more about your findings here?
No, actually, I understand what I have found, but I have maybe one mistake. and the error matrix, I have re-substitution error matrix.
Okay.
Here is 30, 37, and 25, and this is maybe the splitting,
Okay.
maybe the redistribution and error matrix, this is maybe the 70% and this may be the 30%, isn't it?
Yes, right. The error matrix only 30% of the data.
Right.
Okay.
Yeah. Thank you.
Okay, nice. Hey, congratulations. You've completed classification with machine learning. You are a machine learning expert now. Yay!
Thank you.
Okay, anyone want to share their
me.
error estimation? Okay, please do.
It make me doubt about it because my result training overall accuracy is 1.
Okay, 100%.
Is it correct?
Okay. Well, actually, this happens a lot. If you only have a very few sample, usually you get this a lot because this is what you call model overfitting, because the model you develop fit too close to the training data. So this is what happened when you only have a very few sample. Therefore, you can see that the accuracy is 100% due to model overfitting. So there are a few techniques to overcome model overfitting. One of the most used is to increase the number of sample. The second one is to diversify the sample area, not only focusing on, as you can see previously in my script, my sample points spreads all over the area, not focused on a certain area.
Okay.
So if you focus on a certain area, you will experience bias, and therefore the model will overfit because the training data looks almost similar from one and another.
Okay, so I must to increase my AOI, my sample point.
Yes, not only increase sample point, but to diversify the sample point.
Okay. Thank you.
The key thing is your sample area should be representative enough.
Okay, that is a nice way to put it, Mr. Bayu.
Yeah.
Yes.
Yeah.
Yes. So synthesizing from what Mr. Bayu has said, to make our sample, to make our classification not overfit, we have to create a sampling system that is representative, not only on the condition of the mangrove, but also the class that we are going to create. Okay, so this is a good talking point from Mr. Bayu. You have to write it down. I think,
ask Mr. Safran?
Okay, please do.
If we have ground check data, for example, some coordinate for mangrove, some coordinate for Berlin, can we use the data to classify? So we needed to define manually by image. If can, how to do that? Oh,
it's easy. It's easy actually. Just import the data. Just import the data using. So the first thing you do, you upload to asset. Just like what I already show you, demonstrate to you before. Upload the data and then call the data to the project area. And instead of using the geometry import, use the data itself, your data itself. So I'm going to display my screen to show you how it's done. Okay, So the first thing you do, oh, sadly, this one's only on Mangrove, so we cannot use this because there are no other class. But actually, the way to do it is almost similar. You just need to import the script like this. You're going to have a new entry called table, and just replace the table name into new FC. New FC, and then this you have new FC, and then you just delete. You just need to delete this. This step 4. This step 4, you delete the script, but instead you replace it with this. Okay. So it's much easier if you have your training data. So you can replace this Polygon with this one.
Oh yes.
Okay, it's much easier if you have your own training data.
Oh yes.
Okay.
Okay.
Okay. I think in previous presentation by Dr. Worthington, I think he also mentioned the importance of representative sampling, representative and systematic sampling for mangrove classification. So I think it's better to review the lecture from Dr. Worthington, and you can try it in your own monitoring program. Okay. Okay, now, okay, has anyone experienced any type of error?
Yes, me.
Okay, please share the screen. Okay, I'm
I
going to
still
start.
stuck in classification.
Okay.
Let me share my screen.
Okay.
Yeah, I try to display the classification, but and then the error was shown in the console like this. Something is missing. I don't know what is missing.
Habitat feature. Okay, go to geometry imports.
Geometry import.
Geometry import in the map viewer. In the map viewer. Below. Okay, geometry import. Okay, geometry import in the map viewer.
Geometry import.
Okay. Okay. Click on the gear icon. Okay.
What icon?
Yes, I think click on the gear icon. Okay.
Sorry. What icon? Sorry.
The gear icon.
Gear.
Yes, that one.
Okay.
But for mangrove training.
Okay.
Mangrove training. Okay. Nah, in mangrove training, you have to use small. You don't use any capital letters. You use small caps. Okay, small caps. Okay. Click OK. Okay, and now
run again.
No, not yet. Come back. Bear training. You also use capital. Okay. Change the caps into small caps. Okay. Okay. Now, and you have terrestrial vegetation training. Yes. Okay. Let's see the merge function. The merge function. Merge terrestrial vegetation training, merge other training. Okay. Now check the visualization function. Okay. Visualization. Yes, this one. Okay.
The palette.
Yes, the palette. Yes, the palette. You have to have 4, 0, 1, terrestrial vegetation, other 3. Okay. This is this classification correspond with the geometry imports? Okay, go to the gear icon for bear training and terrestrial vegetation. Yes, click there. Okay.
So we have to make same code like
No,
this?
it's not that important, but the value of the property. Bear training. Check the bear training.
Bear training.
Below.
Wait.
Okay, the bear training. Okay.
Mhm.
Okay, Berland 0. Okay. It's the same, Berland. Okay. Next, we go to the other training. Other training. It's 3, and terrestrial vegetation is 2.
Yeah.
Right?
Terrestrial
Okay.
vegetation is 2.
Okay, 2. Okay. Now, okay, we have the now the in map at layer maximum.
Can I say something?
Yes.
Actually, okay. Please, if you go to geometry import and click gear of mangrove training, please. Here, the property is habitat, but other training, you have a different property.
Okay, thank you for noticing it. You have to have the same property.
So all is habitat.
Yes.
All is habitat. Yes.
All property is habitat.
Okay.
Okay, thank you for noticing it. Okay.
Oh, I see.
Okay, habitat. Okay, nice.
And you also have to change the value number of the property. The value number of property you should have to change.
I think he already get the value number right, but the property name is not correct. So you have to have the
I
same.
saw you set the value for the bear training with 0.
Yeah.
Yeah, habitat bear training 0.
Okay.
Yes.
Okay.
Correct.
So the value is okay, but the property.
Yeah.
Yes. Okay.
So I have to change other.
Okay, habitat. Okay.
Okay, let me check the terrestrial. Okay. So
Okay.
all property is habitat. And
Okay,
then
now. Okay, I think you are ready to run the classification one more time.
okay, Bismillah.
Okay. I think it's running smoothly. Yay! I know, not yet. Not yet.
Oh yeah.
Yay!
Okay.
Yeah, if you can continue, please continue with the training accuracy.
This one, yeah.
And the error matrix.
This one, right?
Yes, I think you have a good classification there.
Oh, okay. I want to run.
Oh, 96% of training accuracy. Nice. What about the test accuracy and the kappa test?
Wait. How to check that?
Check the script.
The script
for.
I think Sumiran missed the kappa script.
Okay, I will try to copy and paste it.
Oh, I see. Oh, there is step 9, yeah.
Yeah.
Okay.
No, still in the steps 8.
Step 8.
Oh,
this
still
one.
Oh, okay.
Yeah,
this one.
Okay. Yeah. I'll try. I copy the code, the script. Sorry.
Okay, replace the step 8 with the new. Okay, we try to run. And let's see if your classification system is good enough or not. Okay. Okay, let's check the error matrix. Okay, 70%.
Okay.
It's okay, 70%. Overall accuracy, 70%. It's okay. Kappa test. Okay, 0.6. Usually, if it's close to 0.5, it's very close to random prediction. I think to increase this kappa test, it is better to get the sampling correct, just like what Pak Bayu suggested earlier.
Oh, okay.
Okay, I think you have generally master the machine learning aspect of Google Earth Engine. Yay!
Wow.
Congratulations, everyone! Congratulations, everyone! You are already a machine learning expert.
So the kappa test should be close to value 1.
Yeah, as close as possible to 1.
Okay, I see.
If it's close to, so the general the rule of thumb is like this. If it's close to 0.5, it means that it is very close to random prediction. So you don't have to, you just guess and you have a more like 50% of you are right. So we don't want that. If you are close to 1, then it means that you generally have a good predictive ability of the model. And if you have lower than 0.5 data, it means that your model is even worse than random prediction.
Oh,
Okay.
This is random prediction.
so since it's 0.6, I think it's very close to a random prediction, but you still have a little advantage compared to random prediction. Okay.
Yeah. Thank you very much.
Okay.
Okay,
I hope it's clear for this one. Okay, I'm going to check. Is there anyone having any problem implementing machine learning in Google Earth Engine? Okay, everyone get this done, right?
I have an error when export output.
Okay, please display it. Share the screen.
Okay. Undetermined string constant.
Okay, okay, please zoom to the, I think you have an incomplete incomplete code. Okay, I think the problem is the step 9. In step 9, I'm going to copy and paste the complete code for you. Yes.
Complete.
Okay, so you can change step 9 using the snippet. I copy and paste it to the chat box.
Okay. Copy.
Okay. Oh, hey, you still have the same error.
Excuse me, sir.
Oh.
I think you missed one quotation mark before habitat word in description.
Yeah.
Yeah, in line 97. Description.
Yes.
Before
yes,
habitat,
yes.
one quotation
Yes.
mark there.
Yes, you have to. That's weird. Okay, right. Okay, you are actually correct. Nice to have a very good observation ability of all of the participants. So this is the new script. Yes. Yes. Okay. Okay. Nice. Okay.
Okay. Thank you.
Okay. Nice. Nice. Okay, everyone. Everyone has completed the machine learning. What do you think, guys? What do you feel after becoming an expert in machine learning?
I think it is more simple than I use a standalone application like NV, but we will learn more about the programming.
Okay, yeah. Okay, the learning curve in the programming, actually, yes, you are correct.
Is there some book or some publication that we can learn more about programming image analysis in JEE?
Actually, there are already books in Bahasa Indonesia. You can search it. For English, there are already a lot of publication where it's either it's books. I think it's better if you buy an ebook from Pack or Amazon, because there are a lot of examples, and they also gave the source code if you buy the books from those sources, and then you can try it with your own data set.
Okay.
Okay. Now, after completing the machine learning, now you will do modeling. Way. You'll become an expert in machine learning and modeling after this. Okay, let me continue the presentation. Now, okay, after becoming an expert in machine learning, we will continue how to create modeling with Google Earth Engine. So actually the workflow is actually quite simple. So the generic workflow is first you have to delineate the area of interest, and then you mask the area of interest as necessary, and then you input your observation data to the workspace, and then explore available data sets in Google Earth Engine, and investigate the correlation between observation data with selected predictor, input the formula using expression, and we just export the output. So it's generally these 7 steps, but it is actually you have to customize according to your analysis. So if in this example, previously we have already created the MVI script. So now we're going to reuse the MVI script. So we want to know whether NDVI correlates with MVI, or vice versa, whether MVI correlates with NDVI. Do you have any, does this, do this variable correlates each other? And how much does NDVI affect MVI, or vice versa? So the first thing you need to do from the workflows I developed earlier, we have to create a customized workflow based on the question we have created before. So the first thing you need to do is the delineate area of interest, and then mask using Mangrove area based on MVI. And then you should input your observation data to the workspace. In this case study, we sample the MVI data and explore the available data set in Google Earth Engine and create the NDVI image of the study area. And then we investigate correlation between observation data with selected predictor and input the formula using expression. After that, we export the output. So this is the general idea. The first thing you should do is create a new script from scratch, and then delineate your area of interest. And also in this script, in this script we are going to reuse the MVI script. So please open your MVI script, and then go to your script and double click to open it. You should have your area of interest and MVI. And then we can go to the bottom of your code and start coding there. Okay. Okay. If you have finished opening the MVI script, let's continue to the third step. So what this step do, if you have your own shapefile, you can upload it later on for your exercise. But in this exercise, we're going to use whatever we have in Google Engine for the sake of time. So the first step, we have to provide the input data. In this step, we're going to generate a feature collection of random points, which consists of random point inside the region area of interest with the number of points of 100. And you can copy and paste this script and then click run. Okay. I forgot which one is my MVI script. I think it's, no, it's 13. Okay, this one is my MVI script. And then already have the geometry tools. Now create the input data. Okay. So I'm going to run this script. Okay. See, this one is a feature collection. Feature collection consisting of 100 features. 100 features. 100 features. This one, 100 features. That is made using random points. That is made using random points. Okay. This is the third step to input your data. Okay, the next step, you explore the data set. Because
can you
okay.
Sorry, can you open back your, right? I'm trying to find the one that has my MVI. So just 1 second.
Okay, have everyone opened the MVI script? Okay, I think we can wait for a while until everyone open their MVI script. Okay. Okay, if there's no problem, we can continue. This is script for step 3. Now it's better that we continue to step 4. So we will use NDVI. We're going to explore the data set by creating an NDVI composite and create a palette for NDVI. And then add it to the map viewer. And then the most important thing is we have to stack the MVI layer with the NDVI layer. So this is important. You have to stack 2 layers in order to find out their correlation. And then the next step, we will sample the pixel value as feature collection using the script where the data stack, which is the stack MVI and NDVI layer, is going to be sampled using the feature collection called points that we already declared earlier with the scale of 30. Scale of 30 this is the native resolution of Landsat. So we're going to use the native resolution of Landsat. But if you want to have a different scale, it's entirely up to you. I am going to copy and paste this to the, okay, and then click run. Now I'm also going to paste it in the, okay, step 4. This is step 4. Now you have another, you have a new feature collection called sample. This is a new feature collection called sample. Okay, this is a new feature collection called sample. And then we create a new chart to investigate the correlation of MVI and NDVI. So it's actually very simple. You just comment an engine to plot features using a scatter chart by using this command, the syntax. So I'm going to copy it to the I'm going to copy. Okay. Okay. After you copy and paste this, you are going to have a chart, this one, and at the console. In order for you to get a better understanding of the chart, it is better that you click this icon, the box icon, and then you can also download the PNG files, CSV, or download the SVG files for your publication or report. So like this, we have the formula for correlating MVI with NDVI. So the value of NDVI is actually this function of MVI. Okay, and then you write down this formula, and you can use it in the image expression. Okay. The next thing you should check is the R-square value. This one, the R-square value. As you can see here, the R-square value is quite low, under 0.5. But if you happen to have a bigger R-square value, I think it is good that you have that value. But in this exercise, we're going to continue regardless of the R-square value for the sake of time. And just write down this formula. Just write down this formula and copy paste and copy and paste it in the image expression. Okay. So we're going to continue with the modeling. So we have to input the formula. Actually, you can use operator if you want, but in this exercise, it is better to use an expression because you can see it much easily using expression. The value of not only the value, the variables clearly, And then in this script, there are two parts. The first part is to create a new NDVI based on MVI. Okay, so we predict the value of NDVI with MVI. Okay, the value of MVI, the value of the new NDVI is MVI and calculated using this expression. Okay, now this is the expression, and then after that we map the layer, the new layer, to the map viewer. Okay, now I'm going to display to you how to do that. Okay, okay, like this. So we have a Landsat composite, the composite itself, the MVI inner, and max MVI. We disable the geometry imports. We know there's no need for the geometry import. Okay. And then we have the composite NDVI. This is the composite NDVI. And then the new NDVI created from the calculation. Okay. As you can see here, it's not actually exactly the same. There are differences, I think, because of the R squares quite low. But actually, this is how you create models using Google Earth Engine. So image expression is the key for implementing modeling in Google Earth Engine. Okay. Now let's check. Let's check. Does anyone want to share the result?
I don't mind sharing. I actually found this to be actually almost more accurate than the machine learning in terms of what it's displaying and the way the mangroves wetlands are.
Okay. Okay, please do, please display it. Share your screen.
So it's sorry. Yeah, it's actually picking up on some of the areas a little bit more accurately, and highlighting some of the areas that actually have wetlands more accurately than was shown. There's still some errors, but it's actually this is actually better than I thought it would come out, to be honest. So that's really good.
Can we check the scatter chart?
Say again?
Can we check the scatter chart in the console tab and click the box button? The box button. Yes, that's right. Okay, you have this one. You have 0.5, so you have a better correlation than mine. So it is much better in your area. So that's why you have a better visualization. Okay. So using this principle, you can model almost anything, such as the Mangrove Health Index. In the future, you can use this to model Mangrove Health Index. I think what you did is already correct. And if you want to expand, not only using NDVI, you can also do it. Okay, congratulations, you've mastered modeling with Google Earth Engine. Yay! Yay!
Can I share, Mr. Safran?
Okay, please do, please do.
Yes, so I have done this exercise in the same area previously I have done in machine learning. But I think the result was not good enough.
Okay.
Okay,
Okay,
so
check the,
there
please
is
check.
the scatter plot.
Okay,
Actually, the scatter plot showed that NDVI have some negative value. Negative, almost, here is the MVI -2. Okay, so MVI, can it be -2?
It's okay because it's actually MVI is a relative measure. Relative measure based on the proportion of the green and near end sphere. So it is possible to have negative value, especially when you see a lot of water. Usually they have negative value both in MVI and NDVI.
Okay.
It's okay, it's fine. But I think you've already grasped the principles of modeling using Google Earth Engine. And what I suggest in the future, you exercise more on creating the image in inputting image expression in the inputting formula in the image expression. So in the future, you can create a more complex model. Okay, I think you already mastered modeling with Google Earth Engine. Congratulations, Mr. Rubayo. Yay!
Thank you.
Okay, anyone want to share the result?
Sorry, Mr. Safran.
Okay.
Actually, no, I'm not showing my result, but I just want to ask from the machine learning before that. So is it possible that we use some approach like the maximum entropy to the machine learning and some other approach for the for the results that maybe if I want, for example, if I want to find some plankton in the ocean area or something like that.
Okay, okay. Actually, this is a good question. For the machine learning, you can have a lot of algorithm that you can use. The random forest is one of the algorithm that is available in Google Earth Engine. But if you want to use maximum entropy, it is also possible to use in Google Earth Engine. And if you want to use a simpler algorithm like naive Bayes, it's also possible to do in Google Earth Engine. So you can even compare between one algorithm with the other one and see which performs better in the classification.
Okay, okay.
Okay.
Thank you, Mr. Safran.
Okay, you are very welcome. Is there anyone want to show their modeling result? At least you can brag here. Okay. Anyone want to show their modeling result?
I want to share my problem.
Oh, problem. Okay, please do. Please share.
Maybe I little confused about the name of the variable.
Okay.
So here, line number 11.
Okay. I think the main problem is you didn't use the MVI script.
Oh.
Okay, so try to find the MVI script in your portfolio in your asset. No, in your save script. Yes, in that. No, the script. In script, find MVI. The MVI. Where's the MVI? Any the one with semi-automatic mangrove detection?
Oh yeah.
Yes. Now.
Okay, can I interrupt here, please? Whenever we receive a message like this one, unsaved, sometimes we cannot go back and save things, or maybe we don't know exactly what they are asking or what is.
Okay.
So what shall we do?
There are two ways to do it. First one, maybe you can just create a new tab in your browser and go go to the code editor and just open the new file in the new browser in the new tab, and then you can just copy paste what you have done in the previous one and then paste it in the new tab. In order for you to get both of the data correct. Okay, now go to the okay, right? Okay. Now go to the bottom of the code and paste it there and click run. Now, as you can see, okay, go to the open the scatter chart in the console, scroll down a little bit. Please scroll down a little bit now. Whoa. It's weird. This is the first time I saw this kind of chart. Everything was in the y-axis. Everything is stacked in the y-axis.
So what do you suggest me to do?
Okay, I think if everything is in the y-axis, it's actually means that your area is 100% mangrove. This area is 100% mangrove. So the NDVI is actually the value of the NDVI is actually very close together. So I think that is the problem. If you want to have a variation of the data, you should have more than one type of habitat in your project area of interest. So I think that's the problem. But you can. I think since you have already successful in implementing the script, I think you're fine, but you need to change the area of interest to somewhere else, I think.
Sorry, Mr. Safran, can I interrupt?
Okay, please do.
So I think the calculation of MVI is absolutely wrong, because MVI, all the MVI value have 0. So I think she may be wrong in calculating MVI value.
Okay.
Yeah, I agree, because the MPI value is 0. All of the MPI value is 0 over the graph. I think there is something wrong with the MPI. Maybe better if you check the MPI image.
Okay. So the first thing you need to do is to, actually we should change the area of interest first. Okay, we change the area of interest. No, you don't have to delete the area of interest. Just expand the area of interest. Okay, make it bigger. Just make it bigger.
How can I make it bigger?
Click on the yes, click and then drag. Yes. Yeah, you can just make it bigger like this. Okay.
Okay.
Okay. Now.
Is it enough?
Yes, it's enough.
And
Now,
run
okay, okay, we can just try to click run. Okay, so MVI is almost 0. So, okay, check. Do you mind showing us previously in the okay, in layers, please, in layer properties, please uncheck all layers and display the MVI, max MVI. Only display the max MVI and MVI. Only display the two and MVI. Two layer MVI and MVI. No, the MVI layer, max MVI and MVI layer, 2 layers. Display 2 layer, MVI and yes. Okay. Now click the inspector tab. Click the inspector tab and then click any areas considered as mangrove.
In here?
You can disable the geometry imports first. Okay.
I click the mangrove area.
Yes, mangrove area. Okay, let's check in the inspector tab. Inspector tab, find the MVI value.
Here.
MVI is 1. Oh, okay. MVI is 1. MVI minus 3. Okay, max MVI. Okay, I actually maybe the threshold for MVI in this area is actually not is actually different. So it's actually different. So if this one is minus 3, check the lower threshold to minus 3.
Yeah.
Okay. Check the lower threshold to minus 3.
These are the code.
Yes. Yes. Minus 3.
Oh.
Minus 3.
Yeah.
Okay, and then click run. Okay, let's see. It's actually 100% mangrove. Click on the inspector layer again, inspector, and then click the mangrove area. Mangrove area. Okay, click on the mangrove area. Okay, this one's 4. Go to console. MPI, go to console. Now check expand. Expand the MPI. Use the box. Yes. Now you have a very different graph. Yes. Yeah.
Okay.
Actually, that is because the threshold in the MPI value is different. In Anambas, I think, than in other areas. So this is. Thank you for noticing this error. The different value of threshold for the MPI. Actually, we have a lot of findings in this. Previously, we have different value in the Middle East, but actually, it's much. Even we have different value, much closer to home right now. Okay, nice.
I miss the explanation from you about the threshold. What it means?
Okay, the threshold means that we have to make that we have to make sure that the value of each pixel in the MVL image can be distinguished between terrestrial vegetation and mangrove vegetation. So the value range of mangrove vegetation is generally close together, are generally close together, and the value of the terrestrial vegetation usually outside of that range. So therefore, we have threshold in order for us to discriminate between mangrove and other vegetation. Okay.
So the pixel of mangrove in Anambas is -3. So what can we do is change the threshold, right?
Yes, change the threshold.
Okay.
That's the difference. Okay. Okay. Now, has anyone encountered any error before we declare you as experts in modeling? What do you think, Babayu?
Yes,
sorry, may I?
Yeah, please do, please do.
I also have got the R square is close to 0.
Okay.
Is 0.1. The R square value is 0.108. May I share?
Oh yeah, please do, please do.
I don't know. Yeah, this one. So this is the graph of the NDVI versus MVI, and the result of my new NDVI is like this. Is it
Okay.
correct?
Actually, the first thing is actually MVI is not a good predictor of mangrove health because it is only focusing on the discrimination aspect of mangroves and terrestrial vegetation. Therefore, it cannot distinguish between good mangrove condition or bad mangrove condition. Therefore, having a very low R square, it is actually expected. Okay, very low R square is actually expected, but since this is only an example of what we have, of what you can do with Google Engine, it's actually fine. The main thing that is important is that how you can use Google Engine to model the data using the scientific workflow I provided you with. So the result is actually fine. The value almost very close to 0. It just means that MVI is not a good predictor for ecosystem health. So you have to get a new index for ecosystem health. And therefore, as long as you come up with the model, then it is fine. It is okay. As long as you can implement the principle of modeling in Google Earth Engine.
Okay.
Okay.
But if we, I also would like to asking about the threshold of the MVI.
Okay.
If we get just like in my area of interest, I get the threshold of the mangrove ecosystem is a range between 5 until 6 point, yeah, 0.5, I think. But the threshold in here in this script that I use, the range is 5 until 20. Yeah, I just follow like Pak Safran said that mangrove Indonesia is in the range of the value of 4 until 20 for the MVI threshold. So if I get only 6, 5, the value, I should still use the value like this, or I just change into like 5 and then until 6 or 7, maybe just like that.
Yes, you are correct. Yes, you can customize the lower and upper threshold based on your findings.
Okay. So this MVI did not tell us that if the mangrove is in good condition, yeah, very dense, and if the mangrove is in bad condition, yeah, it's less dense. Is this MVI value can tell us to compare that condition or not? Just if we get the threshold value is higher, so we can indicate that the mangrove area is very dense. But if we get the threshold value of the MVI is lower, or minus, so we can we indicate that this mangrove area is in bad condition or less dense. Can we say like that for this?
No, we can.
Oh.
We can. So the MVI, this index can only discriminate mangrove against other type of vegetation. So it cannot discriminate the condition of mangroves. So it's only to differentiate between classes. So it cannot be used as predictor to predict the condition of mangroves, unlike the NDVI or EVI.
Okay, thank you, Pak Safran.
So the best practice is you use the MVI to mask the mangrove area, and then after that, after you have the MVI, you have the mangrove area, you can calculate the NDVI, and then you can understand which area is better and then which area is currently degraded. So use the mangrove, the MVI to mask mangrove area and to differentiate between mangrove and terrestrial vegetation. So I think that is the best practice. Maybe Mr. Yuda can, Mr. Bayu can add more based on your findings in your research.
I think if you look at in the Balolo et al. 2020 in their paper, you see that there is no correlation between the MVI and NDVI. So this is just for the training, I think, Mr. Sumiran. So don't use this as the basis to model the greenness level with the MPI, because the MPI is not aimed to give you an information related to the vegetation figure or vegetation height. The MPI is aimed to distinguish between the mangrove and other objects, especially with the terrestrial vegetation. And this is just for the practice.
Thank you, Pak Bayu.
Yeah. Okay. Maybe after Mr. Sumilan, Patrice.
Okay. Patrice, please share your screen. Okay.
Okay, I'm seeing this arrow. Not so sure where I went wrong.
Okay. I think you miss just one. I think you miss one item here. Let me check, please. No, you missed something here. Oh, the bracket. The bracket. You missed a bracket there.
Yeah,
yes. Now you got it right. Okay, please check the graph, the scatter chart in console. Check the scatter chart. Click the expand button. Now, oh, you have a better than mine, 0.2. But it is okay. It's not a good predictor, as we have discussed earlier. The MVI is not a good predictor, but you actually have been able to do the modeling. Okay, let's see the script again. Let's see the script again. Okay. Okay. Yes, correct. So, where is the layers? Is it the small? Oh, not yet. The new NDVI. Okay, the new NDVI. Check the new NDVI layer. Yes. Okay. Now we should have a new. Okay, now please zoom to the area of interest. Okay. Okay, you can wait for a while until it finished loading. Okay. Okay, nice. Nice. So this is the your model, but I think since it's not the formula is not very since the R square is not very high, so that's why the model is not very good. But you can also increase the size of your area of interest to get the difference, to get more diverse data in order for the model to be more accurate. So that's one of the improvement that I can give to you. But in general, you have successfully implemented modeling in Google Earth Engine. So it's very important for each participant to have their own repository of scripts that you can reuse, because these are the script that mostly used by scientists in this field. So by using this script, you can always do the analysis with various objects. Okay. Now we're going to continue.
We still have someone raise his hand.
Okay, please.
Mr. Robert.
Thank you, Mr. Safran.
Okay.
So I just wanted to ask Mr. Patrice to share your screen again, please. Can you please?
Okay, please. Miss Patrice, you can share your screen again.
So, Mr. Safran, I want to just ask one clarification.
Okay.
Actually, here the relationship between MVI and NDVI, we are just trying to model a straight line model, but can we fit any nonlinear model? Here the relationship is logarithmic, I think. So can we fit any logarithmic expression
Okay.
here?
Okay. Currently, Google Engine doesn't have that function. Therefore, sometimes to model it, it is better to download. If you click on the expand button, you have the download CSV menu. You have download CSV menu, and you can use the CSV files in other software such as R or MATLAB. So it's since some of the modeling aspect, especially the calculation aspect, not provided in Google Engine, you can download the CSV file and use it outside. And after you get the formula, you can come back to Google Earth Engine and then type in the image expression your new formula. That is one of the things that we can do with by combining Google Earth Engine with other software or other solution.
Thank you, Mr. Safran.
You are welcome. In my example, previously I do research on the modeling of habitat niche modeling. I do a niche modeling since Google Earth Engine doesn't have that function yet. So I just take the data from Google Earth Engine and use other modeling software. And then after that, I input again in Google Earth Engine and play around with the possibility of improving the model. So that's something that you can do also. Okay, now we're going to have your final, your final assignment. Yay!
Oh my God. Congratulations.
Your final assignment. Yay! Now, actually, Mr. Bayu and the team have created Mangrove Health Index and model using MVI. EVI and AVI and NDVI. Is it various indices. So we're going to use that formula. Mr. Bayu will share his publication right now.
Not me, maybe Mr. Eka.
Oh, Mr. Eka, sorry. Mr. Eka will share his publication. Yes, his publication to model mangrove health index in your area. Oh, this is exciting. To model mangrove health index of your area using the formula that Mr. Eka has published. So
okay, I will share later, Mr. Sakan,
okay.
on the group. On the group,
okay.
WhatsApp group.
Okay. Using Landsat 8.
If possible, if we can get the formula now in the chat room, Mr. Eka, if possible.
Okay, can you wait for a while? Sorry.
Oh, yes, sorry.
You just shot me, you know.
Okay, so we're going to create a script to model mangrove health index in mangrove areas using vegetation indices that Mr. Eka has already researched as the predictor from Landsat surface reflectance cloud-free image composite. Okay, so what you need to do first, you have to delineate your area of interest, and then you call the Landsat 8 surface reflectance and create the cloud-free images. And then you can use either MVI to discriminate mangrove areas and non-mangrove areas, or you can use machine learning to discriminate mangrove area and non-mangrove areas. And then use vegetation index, use the formula of vegetation index to come up with the mangrove health index in that mangrove area. Isn't that exciting, everyone? You're going to model your own area, and you can find out your mangrove health index in your own area. And the deadline is the end of this training period. Okay?
It's easy. Tomorrow.
Okay, anyone has a question related to the final assignment?
Don't worry, you can call a friend.
Okay, so if you want to download the complete script, it's also available in the Marta toolbox in DOI, in this DOI, and use it accordingly. And we hope that this training here we go. Okay.
Yeah, please. Can you explain this, Mr. Bayu?
Okay. Okay. Please, Mr. Bayu or Mr. Eka can explain the formula of mangrove health index.
Yeah, Mr. Eka, please.
Okay. We build this index using multivariable correlations, using multiple regressions, and we found that 4 vegetation indices here, and I don't know what is the principle of this, but I think Mas Bayu can explain later. All of this
NBR.
Yeah, NBR, and then DCI, and CPI, and RV. We use this, and we have already clearly defined mangrove health index using this formula. So I think you need to define this one by one first. Yeah. After that, you can calculate the mangrove health index. Yeah, it's easy, I think.
Yeah.
Okay.
Yes. So
Mas Bayu, maybe do you have any explanation?
Yeah, just adding Mr. Wayan comment. So the NBR refers to the normalized burn ratio index. So this index is commonly used for detecting X forest burn area, and the advantage of this index is this index will detect which area is dry, something like that. So if you use this for the detecting mangrove or for the assess the mangrove health or some kind like that, you can see if the area is dry, and then the mangrove will be not good condition, something like that. But this is the common case. But in the special case, for instance, in the Merauke, Pak Eka, I think Merauke is the same case with the mangrove in the Bahrain, because the mangrove live in the dry area, far away from the coastal area. That's the special case. And then also another indices here we have CP, ARVI, and also GCI. This is I think this is the same, the similar indices that highlight the greenness level, still the greenness level, but the difference is how they combine the greenness spectrum in the near infrared with the other spectrum, such as blue, red, and the green color. So I think this my general information. I think if you want to know more about the indices, you can directly to search the source of the index in the related paper. I think that's all, Mr. Eka.
Yeah, the full publication is available at the chat.
Oh yeah.
Okay, everyone. So this will be my last session. Thank you very much, and congratulations for at least surviving. Thank you for staying alive until this very moment. I hope I didn't bore you to death. And please do the homework and the final assignment. And tonight I'm going to open for Q&A session for about 3 hours. And please, if you happen to have any question or difficulties in implementing the Google Earth Engine, you can contact me directly also in the future. And if you want to have collaboration with us, the Indonesian scientists, we can also talk later on. Okay, thank you very much for your attention, participation, and enthusiasm. And thank you very much for the support of the committee, Mr. Bayu, and also Mr. Eka and
Mr.
the other
Safran,
team. Yep.
Mr. Safran, in the last day you also in, right? In the last day.
Oh, I will only support Mr. Yaya. So I'm just an additional guest star. Additional guest star. But I think this is my last session. Thank you very much, everyone. Assalamualaikum warahmatullahi wabarakatuh. I'm returning to the moderator, Mr. Eka. Thank you very much.
Mr. Yunus, are you there?
Mr. Eka, your name is mentioned.
Okay.
Mr. Yunus. Okay, sorry, Mr. Yunus.
So I think for this maybe before ending the sessions, we need to take a photo session, I think.
Yes.
Photo every day. Photo every day.
Okay. So second, please. Second. Okay. Sorry. Okay. Well, okay, we are having photo session with Pak Safran and also with Pak Eka and me. Okay. Page 1, guys. Yeah. 1, 2, 3. Okay, a second. Okay, next, page 2. Okay. 1, 2, 3. Okay, thank you very much. Terima kasih Pak Sapran, Pak Eka.
Okay, thank you very much, everyone. Thank you, Pak Yunus. Thank you, Pak Safran. You have shared not only to the participant, also to me, teach me how to use the Google App here, the powerful tools to map the mangrove and also doing the analysis of the mangrove. And don't forget, in the last day, we also still need your assistance for the mangrove health index distributions. Maybe for our last assignment, I think, yeah. And without further ado, I think the session today is closed now. Thank you very much for your attention, your boring sometimes. Okay, and see you tomorrow.